Some of the terms and explanations related to statistics can get overwhelming, so I'm trying to start with some of the basic ideas. You might find that they're fairly logical when it comes down to it. Here's an example that might help explain why I say I think this is fairly logical. The focus in this section is what we need to know to select an analysis. The main idea is that we need to treat different types of data differently. For example, I can use numbers to identify whether my participant was male or female, and using numbers can make data entry much faster. But does it make sense to average those numbers? If I used a 1 to identify female participants and 2 to identify males, does it make sense to say my average gender is 1.5? Not so much, huh? That example illustrates two important concepts: scales of measurement and statistical analysis. I hope the learning materials and activities for the unit helped you understand the characteristics of the different scales of measurement. As you may have already noted, gender would be measured on a nominal scale, even if we use the numbers 1 and 2 to code the different groups. Note that I included the approximate interval scale in the list. When we use response scales, it can be argued that the responses really represent nominal or ordinal data. But that limits our analysis somewhat, and it's become common practice to treat the resulting data as interval data. Given that it can be a little confusing, I want to make sure and highlight that idea. That's part of the reason I like the scale of measurement workshop from Wadsworth that I included in the learning activities for this section. When we conduct statistical analysis, we start with the descriptive statistics. In the case of frequency research, we start and end with descriptive statistics, as that's the focus. That means we'll likely include more descriptive information than we would include if there was just the first step leading to inferential tests. Descriptive statistics describe the center point for the distribution of the data and the variation from that center point. The idea of a center point can be defined differently though, and in some cases, with some scales of measurement, some definitions do not make sense. For example, the mean is the average of the data, but it doesn't make sense to compute the average of variables measured on the nominal or ordinal scales, as illustrated by the gender example. When we combine our understanding of scales of measurement with our knowledge of descriptive statistics, we can match which scales and which analyses work together. Note that we can use any of the descriptive statistics for interval and ratio data. It's the nominal and ordinal scales where we are more limited. In those cases, we're limited to reporting how many participants provided a particular response. Percentages help us convey that information more easily in some cases. For example, if we just said the mode was cat, it's less meaningful than saying 60% of the participants said they preferred cats.